Here we are in Chapter 5, Review 1, exercises 21 through 28, and we are factoring. It doesn't tell us which method, so we kind of need to find our own methods. And this is the steps following to factoring polynomials. Notice how we always pull out the greatest common factor first, then we look at the number of terms. It could be 2, 3, or 4 that we know how to factor. If it's 4, we do grouping. If it's 2, we check to see if it's the difference of squares, and if so, we do it. If it's 3 terms, each polynomial will follow a certain path down here. So we have a small version that I wrote up to guide us, greatest common factor 2, 3, or 4, that'll help guide us a little bit on this other screen. But if you need to, go ahead and reference that big one out of your textbook. All right, number 21. First step, pull out the greatest common factor. Looks like there is a 2 in everything here. When we pull that out, we get 9x squared plus 12x plus 4. Okay, so we go down here. We have 3 terms left. Leading coefficient is not equal to 1. And so we check to see if it is a perfect square. Well, 9 is 3 times 3 and 4 is 2 times 2, so it probably is 3x plus 2 squared. Remember, what is the pattern? A squared plus 2ab plus b squared. When you multiply all that out, yeah, we got to look to see if this middle term here, 12x, is 3 times 2 doubled. 3 times 2 is 6, doubled is 12. It works, and that 2 just floats. So that's how you do perfect squares. All right, next one, number 22. X squared plus 7x minus 18. Is there a greatest common factor? No, there is not. So we look, and there are 3 terms, 1, 2, 3, and the leading coefficient is equal to 1. So here we look at this number, negative 18, and we see what multiplies up to 18 and equals to a positive 7. So we could have a 1 and an 18. Nope. 2 and a 9. Ooh, that's a possibility. Or a 3 and a 6. Now one of these has to be negative. So if we put negatives over here, we'll notice this one adds to positive 17. That one adds to positive 7. There's our magic pair right there. And that one adds to positive 3. So we just put it into parentheses. I like this one. X plus 9 and x minus 2. There we go. Number 23. Ooh, is there a common factor in all of this? Ooh, yuck. That doesn't look good at all. That has 3s and 6s and 9s, and that has 3s and 5s. So we got 3s so far. 3s, oh, 3s are looking good. Oh, not on that one. Let me see, between 20 and 18 is a 2, but no 2 and 15. So no, there's nothing common there. Okay, so how many terms? 1, 2, 3, 4 terms. So we are in grouping. Chainsaw. What can we take out of that? Looks like a negative 3x squared. And what are we left with? 6x. And if we take it out of there, just a 5. All right, and what can we take out of the second half? Looks like take that sign out, plus a 4, and we're left with 6x minus 5. So that means we can take out, oh, I messed up here. That's not 6x plus 5. Let's go back. Let me do that right. If I take a negative 3x squared out, whoa, those two didn't come out to be the same. It was going to be prime, but no, when we take out a negative 3x squared, that's a minus 5 right there. Then we move to the next set, take out that positive 4, and have a 6x minus 5. And then take out that 6x minus 5, and we're left with that negative 3x squared plus a 4. Oh, good. Number 24. Negative 20x squared minus 19x minus 3. Greatest common factor, what we look for first, not in there. 3 terms, the leading coefficient is not equal to 1. Let's check to see if it's a square. Nope, those are not perfect squares. So we're going to do the AC method where we take negative 20 times negative 3 is a positive 60. This could be 1 and a 60, 2 and 30, 3 and 20, 4 and 15. Oh, there's our 19 right there. 5 and 12, 6 and 10. All right, so it's going to be a 4 and a 15. They both have to be negative in order to equal the negative 19. But notice here we don't just put them in parentheses. It says split b. So this negative 19x actually came from negative 20x squared minus 4x minus 15x minus 3. Oh, whoa, look at that. Okay, so we can take out, where do we go after that? We now have 4 terms, so we group. Chainsaw, take out a negative 4x, and we're left with 5x plus 1. Make sure I pull that negative out correctly. And then in the second half, I get a minus. What comes out with a 15 and a 3? It looks like a 3. And we get 5x plus 1. Okay. So that means we can pull that 5x plus 1 out. And we're left with that negative 4x and minus a 3. So you could write it like this if you wanted to pull a negative 1 out of this factor here and have a negative 1 and then 4x plus 3, 5x plus 1. That would be all right. Excellent. Number 25. Negative 3a squared xy plus 3b squared xy. Let's see if there's a greatest common factor. Certainly there's a 3. We can pull a negative 3 out or a positive 3 if you wanted, either one of those. A's. Nope, A's aren't common, but x and y are. I just wrote x squared y, and we're left with a squared minus, pull out the 3 and the xy, b squared. So what's left here has 2 terms, 1, 2. Is it a special case, a squared minus b squared? It is. Remember how these go. This is a minus b, a plus b. Okay, so that's negative 3xy, and then that guy breaks up to a plus b, a minus b. Yeah, we weren't quite done. That guy still could go down a little bit. All right, number 26. Let's check for a greatest common factor. First, always do that one. Nope, there's not one in there. So we look, there's 1, 2, 3 terms, leading coefficient equal to 1. So this is, we just need to find numbers. We know there's an x and an x. We just need to find numbers that times up to 56 and add to a negative 15. 1 and 56, 2 and 28, before and looks like cut in half 14, or 7 and 8. And that's our magic pair. If it's a negative 7 and a negative 8, just double check. Those two times to a positive 56 and add to a negative 15. That is correct. X minus 7, x minus 8. Good. Number 27. X squared minus 23x plus 132. Is there a greatest common factor in there? No. So we check how many terms. 1, 2, 3. Leading coefficient 1. That means we're going like this with an x and an x, and 132 right up here. What times this to 132 and adds to a negative 23? 1 and 132. 2 and what is that? 66. 3 and 44. 5, 6, and 22. 7. Oh, I missed a 4 in there. 4 and 33. 6 and 22. 7, 8. Nope. 9. Nope. 10. Nope. 11 and 12. Oh, that's our magic pair right there. Negative 11 and negative 12. They times to a positive 132 and add to a negative 23. Minus 11, minus 12. Whew, some of those are kind of tough to find those things. You just have to keep going until you find the pair that work. All right, so now number 28. Greatest common factor? No, this only has x's, that only has numbers. Count up the terms, 1, 2, 3, leading coefficient 1. Oh, we've had like 3 of them in a row like this. That's nice to be able to practice those. An x there and an x there. Negative 45 is C, so what times is to a negative 45? We get 1 and 45, 2, 3, and 15, 4, 5, and 9. And that's all we got. So add up to a negative 4. Now this is a negative 45, so these are opposite of each other. Looks like we'll have to have a negative 9 and a positive 5. Yeah, there we go. So positive 5 and negative 9. They actually times to a negative 45, add to a negative 4. So if you multiply this out, that's exactly what you get. Excellent.